In this lesson, we're going to talk about evaluating functions, and this is a continuation of previous lessons dealing with evaluating functions. In particular, in one of the previous lessons, you learned about the algebra of functions. So you learned that given two functions, you can add those two functions together. So remember the notation. So when you see something like this notation, by definition, that means this. So f plus g at x means f of x plus g of x. And then there's a difference. So f subtract g at x is equal to f of x minus g of x. Now remember, when you're dealing with subtraction, the order matters. So whatever function is listed first, see f is listed first, it must be listed first. All right, so that was discussed as well. Then there's a product. So the product two functions, f times g at x. So remember, there's no operation there. It's understood to be multiplication. So f times g at x means f of x times g of x. And then the quotient. So you have the quotient of two functions, f and g, at x, and so that's defined to be f of x divided by g of x. So just like with subtraction, the order matters. So whatever is listed in the numerator must be listed in the numerator. And remember that quotient exists as long as your denominator is not 0. Okay, so that's something you have to remember for what we're about to do. Okay, so in number 1, so let's suppose we had number 1, and the directions will say f of x, let's say, is negative 2x squared minus 5x. And you want to find g of 2. All right, so you basically had this in a previous assignment in previous lessons, and so remember what that means is you go to your function. That's supposed to be f, excuse me. So you know that couldn't work because that was function g. So you want to find f of 2. So you go to your function f, and where we see the variable, you substitute 2. Okay, so f of 2 then would be negative 2 times x. I'm substituting 2 in for x, but I'm squaring it, minus 5 times 2. And so using the order of operations, and be careful because some students will say f of x equals this. No, f of x doesn't equal that. F of x equals this variable expression here. All right, that's what f of x equals. F of 2 equals this. So what you write does matter. So always keep that in mind. You have to say f of 2 equals this, not f of x, because that's f of x. F of x has the variable x in it. F of 2, you're substituting the value 2. So you must say f of 2 equals this. You see there's no variable anymore. You're substituting that variable x, and you're substituting 2 for it. Okay, order of operation, I got to square before multiply. So 2 times 2 is 4. 4 times negative 2 is negative 8. And then a negative 5 times 2 is a negative 10. So f of 2 equals negative 18. Okay? All right, so that means that if you were looking at the graph of this, and that would mean that when x is 2, y is negative 18. So that means that the point negative 218 would be on that graph. All right, so that's one of the things that means. Okay, number 2. Let's suppose you have f of x is x squared minus 3x plus 1, and g of x is 6 minus 2x. All right, so you're looking at these two functions, and you want to find f minus g at 3. Okay, so that's going to go back to our algebra of functions. So notice that we are subtracting g from f at 3. So what we're going to do is we're going to use our definitions. That means f of 3 minus g of 3, right? And so I go off to the side. Remember, you go off to the side and you kind of figure out, well, what is f of 3? Well, here's my function f of x. You got to make sure you use the right one now. So this is f of x. And so f of 3, I'm going to go off here and just do that. So f of 3, then where we see the variable x, I substitute 3. So I get 3 squared minus 3 times 3 plus 1. So notice I am saying f of 3 equals this. And you really need to put parentheses there, especially if this were negative. Okay, so 3 squared is 9. Minus 3 times 3 is 9 plus 1. So 9 minus 9 plus 1 is 1. So f of 3 is 1. So go off now and you say that equals 1. Okay? Subtract don't forget you're subtracting, so go ahead and write subtraction right now. Now you got to find g of 3. G of 3. Well, you go to your function g, and in place of the variable x, you substitute 3. So I get 6 minus 2 times 3. So that's 6 minus 6, which is 0. So that's 0. So therefore, f minus g at 3 will equal, now remember that's 1 minus 0, which is what? 1, right? So f minus g at 3 is equal to 1. Okay? So basically, if you were to look at those two graphs, then 3, 1 is on this graph, and 3, 0 is on this graph, and then basically you're just adding the y coordinates. 1 plus 0 is 1. Okay? All right, so we're going to look at that situation in a little while. All right, number 3. Number 3, let's suppose you had h of x is 2x minus 1, and g of x is the square root of x plus 5. All right, so h of x is 2x minus 1, and g of x is the square root of x plus 5. So we want to find, I'm going to go ahead and put an a part here and a b part. So in a part, let's go ahead and find h times g at negative 2. H times g at negative 2. All right, so by definition, again, we're using our algebra functions, using this. So that's the product of two functions. So by definition, that means h of negative 2 times g of negative 2. Okay? So h of negative 2 times g of negative 2. So again, you want to find h of negative 2 and g of negative 2. So let's find h of negative 2 first. So I go to my function h, and I'm going to substitute negative 2. So I get 2 times x, which is negative 2, minus 1. So 2 times the negative 2 is a negative 4. Negative 4 minus 1 is a negative 5. So h of negative 2 is negative 5. So that means this right here is negative 5. Okay, so that's what I have so far. So notice the where I'm putting the work and what I'm doing as I go through each step. All right, so you got to make sure it makes sense, whoever's looking at this. So there's your thinking process. You know that h of negative 2 is negative 5. So you say, well, okay, so now this right here, this factor right here is negative 5. Over here, I got to find g of negative 2 now. So let's go off to the side again, and let's find out what g of negative 2 is. So this time I'm going to go to my function g, which is this. And so where we see the variable x, I'm going to substitute negative 2. So I get negative 2 plus 5, which is the square root of 3. And I cannot simplify that, so that's the square root of 3. So this becomes times the square root of 3. Okay? Oh, the square root of 3, excuse me. Times the square root of 3. All right, now you got to rewrite this in a better way. So here's how I'm going to tell you need to rewrite this. Don't leave it like this. That looks not good. So what you got to do is say, all right, so the answer, then you're going to say h times g at 2, negative 2, excuse me, equals, and in the blank, you're going to say, all right, now negative 5 times the square root of 3 is negative 5 square root of 3. See how much better it looks? Okay, so just keep things in mind. Just you have enough prior knowledge to know how something is supposed to look. All right, so negative 5 times the square root of 3 is this. All right, now let's look at b, because sometimes you'll see something like b, and so you need to know what to say. All right, suppose I want to find this. Suppose I want to find, let's say, h plus g at, let's say, negative 7. H plus g at negative 7. Okay? All right, well, by definition, that means h of negative 7 plus g of negative 7, right? Okay, no big deal. So we got it so far. So then we got to go and find h of negative 7, right? So h of negative 7, then I go to my function h, which is here, and in place of x, I'm going to substitute negative 7. So I get 2 times negative 7 minus 1. So we multiply before we subtract, so order of operations, keep that in mind. So negative 14 minus 1 is a negative 15. Okay, so I'm good so far. So far I got this. Plus, all right, let's find this, g of negative 7. So g of negative 7 will be the square root of negative 7 plus 5. And so the square root of negative 7 plus 5 is the square root of negative 2. Well, remember, that's undefined because you can't take the square root of a negative number. Now, you may say, well, isn't that an imaginary number? Yeah, but we want these, when we're talking about functions, we're talking about, remember, when we talk about functions, now we're talking about these being real numbers. All right, so this is not a real number right here, right? So this right here is not a real number. So we say that h plus g at negative 7. Now you could see one of several things. You could say does not exist. All right. You could say not a real number. Okay. You could say something like that. All right. So does not exist, not a real number. Okay. Some students could say undefined. So depending on your textbook, and if this is multiple choice, just know that it may be something that looks like this, that you would have to write. Okay? All right, so I just wanted to bring that up just in case you might see something like this. All right, number 4. So let's do number 4. All right, so number 4, let's suppose in number 4, we have f of x equal x squared minus 8, and g of x equal 12 minus x. All right, and you want to find, and let's do two things. You want to find a, which is f divided by g at, let's say, negative 2. Okay, so f divided by g at negative 2. Oh, that's capital G, excuse me. See how I put a lowercase g here? This is capital G, so you got to make sure you say capital G. All right, so remember, notation is important with these because these are the names of the functions. So this is capital G of x, this is capital F of x. So names are important. So by definition, that means f of negative 2 divided by g of negative 2. All right, and so we got to figure out, well, what is f of negative 2? So I'm going to go off to the side and kind of do that. So I'm going to go to my function f, and in place of the variable x, I'm going to substitute negative 2. So I get negative 2 squared minus 8. So negative 2 times itself is 4. 4 minus 8 is a negative 4. So that's the numerator. Okay, no big deal. We got this. The denominator, g of negative 2. So this time I'm going to go to my function g, capital G. And so I have 12 minus x. Oops, sorry. 12 minus x, which is, and x is a negative 2, right? So this becomes 12 subtract a negative 2. And remember, this says 12 subtract a negative 2. So remember, you're going to need to change this to an addition problem. So when you change this to an addition problem, that becomes 12 plus 2, which is 14. So then this becomes 14. But sometimes you may be asked to reduce this. So write this in simplest form. So you're going to want to say, remember that they're both even, so they're both divisible by 2, so it'll be a negative 2 sevenths. So the answer, then you'll say f divided by g at negative 2 is equal to a negative 2 sevenths. Okay? Now, just out of curiosity, suppose I had this. Suppose I had, let's say, f divided by g at, and let's say 12. Okay? So f divided by g at 12. All right, so I find f of 12 first. So, well, by definition, that means f of 12 divided by g of 12, right? So let's go ahead and figure out what f of 12 is. So f of 12 then would be, remember, this is my function f of x is x squared minus 8. So that's 12 squared minus 8. So that's 144 minus 8, which is 136. So that's the numerator. The denominator, though, you want to find g of 12. Well, your function g is this linear function, 12 minus x. So that's 12 minus 12, which is 0. So the denominator is 0. All right. So then remember, you cannot divide by 0. You have a fraction, you cannot divide by 0. So then you could say one of several things. F divided by g at 12 equals blank, you say undefined. All right, so undefined. And you may, depending on the textbook, they may have, instead of the word undefined, they may have does not exist. All right, does not exist. They may have something like that. Okay? All right. Okay, so that was number 4. All right, now let's look at this situation now. Now we're going to look at some graphs. Let's look at some graphs now. So let's suppose we had this, and this is going to be number 5. It's number 5. So let's suppose in number 5 we have this. So notice that this. Remember in the previous problems you were given the two functions as expressions. So you have f of x was this expression, g of x was this, right? So this was quadratic, this was linear. Now what's happening is instead of you given the expression, you're given the graph. So you see how f of x is quadratic and g of x is linear? So instead of you being given the expressions and you substitute, what you're going to do is you're going to find these using your graphs. And for some students, that's a lot easier to deal with. All right, so let's look at this. All right, now, letter A. So I'm going to go off right here and do this. So A says you want to find f plus g at 2. Okay, so f plus g at 2. All right, well, first of all, by definition, that means f of 2 plus g of 2. Okay? All right, now, remember, this is f and this is g. In terms of your graphs, this is your function f, see that? And this is your function g, okay? All right, now listen carefully. And you may need a ruler to help you with. It doesn't matter, whatever age you have to use. So if the graph is given, then what this means is this. I got to go to the graph that represents the function f. And remember, f of 2 means this. What's the y value when x is 2? That's what you're asked. What's the y value when x is 2? All right, so I go to my function f, and here's, you see, x is 2 right here, right? Okay, so you use a rule to kind of help you. So when x is 2, here's the point I'm dealing with, right here. So what is this y value right here? What's that y value? The y value is 4. So do y'all agree that f of 2 is 4? Okay, so f of 2 is 4. Okay, so let me go ahead and kind of make this a little bit smaller so we can see this, the whole thing. All right, so f of 2 is 4. So right here, when x is 2, the y value is 4. So remember, f of 2 means what's the y value when x is 2. All right, so now we go here. So plus, and we got to find g of 2. So question is, where do I go to find g of 2? Do I go to this graph, the quadratic function, or the linear function? I go to the linear function because that's the function named g. So this time you're asked, well, when x is 2, what's the y value? When x is 2, what's y value? All right, so again, use your ruler if you need to. So here's where x is 2, right? So that's this point here, y'all agree? That's this point here. So f of g of 2 then is what y value? G of 2 is 1. Okay, so that's 1. So therefore 4 plus 1 is 5, right? So now we know this. We know the answer now. So the answer is f plus g at 2 is equal to 5. Okay? All right, B. In B, you want to find f minus g at negative 1. So f minus g at negative 1. Well, by definition, that is f of negative 1 minus g of negative 1, right? Okay, so again, you go to function f, you go to your function g. So let's find f of negative 1 first. All right, so f, remember, is this quadratic one. So when x is negative 1, do y'all see that your y value is negative 1, your y value is 1? Okay, so negative 1, 1. All right. Minus. Now let's find g of negative 1. So notice I did this right here. So f of negative 1 is 1. Minus. Now let's find g of negative 1. So g of negative 1, I go to my linear function because that's g. And when x is negative 1, see, that's where x is negative 1. That's this point right here, right? This point right here. So what is my y value? Well, my y value is negative 2 right here. Okay, so when x is negative 1, my y value is negative 2. So this becomes 1 minus a negative 2, which is 1 plus 2, which is, so it becomes 1 minus a negative 2, which is 1 minus a negative 2, which is 1 plus 2, which is 3. Okay, so the answer then will be f minus g at negative 1 is equal to 3. Okay, so it kind of makes sense because look, so you're subtracting, right? So if you look at negative 1 right here, you're looking at these two y values. What's this y value here? Well, that is 1. What's this y value here? Negative 2, 1. Remember, you got to do the function f first. So 1 subtract a negative 2 is 3. All right, see, you have this notation right here. Right here. So remember, there's no operation there, so this to be multiplication. So this becomes f times g at negative 3. So that's f of negative 3 times g of negative 3, right? So f of negative 3 times g of negative 3. Okay, so then we got to find f of negative 3 first. So I go to my function f. So remember, we're finding f of negative 3 first. So I go to my function f, and here is where negative 3 is. I'm using my ruler to kind of help me locate that point. So that's here. So what's that y value? Do you all agree that y value is 9? So when x is negative 3, my y value is 9. All right. So here's negative 3. So you have this point, and then you're also going to be looking at that point, right? Okay. So let's look at this one first. So when x is negative 3, my y value is 9. So this right here is 9. Y'all agree? Times, let's find g of negative 3. So remember, your x value is negative 3 for both of them. So here's negative 3. So we have to look at this point and this point. So when x is negative 3, what's the y value here? Well, the y value is negative 4. Okay, so negative 4. So 9 times a negative 4 is a negative 36. Negative 36. So 9 times a negative 4 is a negative 36. So then the answer, then you're going to say f times g at negative 3 equals a negative 36. All right. Now let's look at D. So D says this. So D says, this is 5D. So 5D says you want to find f divided by g at 2. Well, by definition, that means f of 2 divided by g of 2. And so for both cases, your x value is 2. So just look at your ruler right here, f of 2, right? I'm sorry, x equal 2, right? So here's f of 2 right here. Question is, what's that y value? Well, that y value is 4. Okay? Make sure you see this. That y value is 4, right? Okay? So f of 2, the y value is 4, so that's the numerator. G of 2, so that's your linear function. G of 2, so when x is 2, your y value is 1. Y'all agree? And so therefore, 4 divided by 1 is 4. So the answer you're going to say f divided by g at 2 equals blank, so it'll be 4. All right? So remember, you're taking, what you're finding here is you're finding the quotient of these two functions at 2. So if you look at your ruler right here, so this is the value 4, this is the value 1, 4 divided by 1 is 4. All right, E. So E, you want to find, it looks like you want to find G divided by F at negative 1. So the quotient of G and F at negative 1. Okay, so the quotient of G and F at negative 1. So by definition, that means G of negative 1 divided by F of negative 1. And so you want to find those two function values when x is negative 1. So look at your ruler right here, negative 1, right? Okay, so you're looking at these two values, these two y values. So this y value, when x is negative 1, this y value is 1. So I get 1 up here. Oops, sorry. That's down here. Okay, so f of negative 1 is 1. So be careful, make sure you put it in the right place, okay? G of negative 1 we found to be, here's G right here. So when x is negative 1, your y value is negative 2. All right, so G of negative 1 is negative 2. So that simplifies to negative 2. So if you can simplify it, you go ahead and simplify it. If you can reduce it, you reduce it. So your answer then is g divided by f at negative 1 is negative 2. Okay? All right, let's look at another graph. Well, before we go on, so you do realize, you see how it's how this involved a little bit more work to find these values because you had to substitute into these expressions. Here, it's easier if the graph is given because you just read the y values. You're reading the y values from your graph. Here, the y values, you see when you find f of negative 2, that's your y value. You're finding the y value by substituting x into your expression, into your function. All right, so it's easier if the graph's given, but it's not always be given. So you'll be given your variable expressions, and then you'll be given graphs at times. And then you're going to see in a little while you can be given a table as well. All right, so let's look at the next problem. Okay, so this time this could be number 6, and so notice you have these two linear functions. All right, and you're gonna need your ruler to kind of help you locate where those points are. If you need to, go ahead and use that. Now the direction says use these graphs. So here's the function f of x, here's the function g of x, to evaluate each of these expressions. Okay. All right. So I'm gonna go ahead and use a separate sheet of paper so I can have that's right here in front of me. So in letter A, so this is number 6A. So in 6A, you have g minus f at 4. All right, and by definition, that means g of 4 subtract f of 4, right? Okay, so I want to evaluate these two functions when x is 4. So I'm trying to find these two y values. That's what you're trying to find, those two y values. So I'm going to locate x equal 4, which is here. Okay, x equal 4 is here, right here. And so remember, when x is 4, so I have this point here, and you're trying to find this y value. So remember, this y value is 8, right here. That's 8. So this point here is 4, 8. And when x is 4, this point here is 4, negative 1, right? Okay. So what we have is this now. So the question is this. When x is 4, what is this y value? 8. And when x is 4, what's this y value? Negative 1. Okay, so g of 4 means what's the y value when x is 4? So I got to go to my function g, though. Be careful. This is f. This is g. So you have to be careful. Make sure you put the right one there because this is subtraction. You remember with subtraction, the order matters. So you got to put g of 4 first. So g of 4, this is g right here. G of 4 is negative 1. So you got to put negative 1 first, okay? Then you're going to subtract. Now we got to find f of 4. Well, here's my function f. When x is 4, my y value is 8. So this becomes negative 1 minus 8, which is negative 9. So your answer, let me put the answer here. So the answer, g minus f at 4 equals negative 9. Okay? All right, let's get the next one. So B part, they want you to find this product now. So f times g at 1. So f times g at 1. So B, you want to find f times g at 1. By definition, that means f of 1 times g of 1. All right, so same idea. Where we see, so we want to find the y value. Remember, you're finding y value. So we want to find the y value when x is 1. Okay, so you want to find f of 1, g of 1. So I'm going to use my ruler to help me. So here is where x is 1 right here. And so I'm going to get this point right here and this point right here, right? Okay, so when x, and be careful, remember this is f of x, this is g of x. And since this is a product, it really doesn't matter, right? Because the order in which you multiply does not matter. The order mattered here because you're subtracting. So that's why I said you got to be careful. You put see, if you had put 8 first, you would have gotten a different answer. You would have gotten a positive 9 instead. All right, so you got to be careful. All right, so f of 1, let's do f first, since it's listed first. F of 1 means this. When x is 1, the y value is 5. So that's 5, okay? Times g of 1. So g of 1 That's this one here. So that's your function g. See, that's your function g. So g of 1 means when x is 1, the y value is 1. So my y value is 1. And so therefore 5 times 1 is 5. So the answer you're going to say is that f times g at 1 equals 5. So that means if I take this y value and take this y value and multiply them, 5 times 1 is 5. Okay? C. So C, you want to find this quotient of the function f and g at negative 2. So f divided by g at negative 2. Well, by definition, that means f of negative 2 divided by g of negative 2. Now remember, subtraction and division, the order matters, so you got to put this in the numerator. You got to look at the numerator first so you don't mess up. So this time I want to find the y values when x is negative 2. So here is where x is negative 2, right here. Okay? So I'm going to darken this to help me. So I'm going to darken those. And so when x is negative 2, let's do f of negative 2 first. When x is negative 2, here's f. My y value is what? What's that y value right here? That y value is 2. Okay? So my numerator is 2. Now we got to find g of negative 2. So g of negative 2, here's g. So when x is negative 2, my y value is 3. So the answer is 2/3. So the answer you're going to say is that f divided by g at negative 2 is 2/3. So you're looking at the quotient of f at g at negative 2. And then letter D, you want to find this now. So letter D, you want to find g plus f at negative 5. Okay, g plus f at negative 5. So it helps if you go ahead and kind of darken those points. So here's where x is negative 5, and so you want to find the y value of this point, and you want to find the y value of this point. Okay, so negative 5. So remember, by definition, this means g of negative 5 plus f of negative 5, right? And so let's find g of negative 5 first. So g of negative 5, this is your function g, so that's this point here. So when x is negative 5, what's that y value? This y value is 5. So we'll put 5 right here, plus, now we got to find f of negative 5. So f of negative 5, that's this function here. So f of negative 5, so when x is negative 5, what's this y value? This y value is negative 1. So then I get 5 plus negative 1, which is 4. So your answer then will be g plus f at negative 5 is 4. Okay? So basically what you're doing, remember what you're doing, you're adding these two y values. You're adding these two y values. And when you add those two y values, you get 4 as a sum. All right, so that was number 6. Okay, let's look at number 7. So number 7, let's suppose we had this. So this is number 7. Okay, so here's my function f right here, and here's my function h. So this is h, this is f. All right, and you want to find, you want to use these graphs to evaluate each expression. All right, so let's look at the first one, letter A. So this is 7a. So 7a, you have f plus h at 2. All right, so by definition, that means f of 2 plus h of 2, right? And so I got to find these y values. So remember, f of 2 means what's the y value when x is 2. That's what that means. So you got to put the y value here. What's the y value when x is 2? Okay? So here's where x is 2 right here. All right, so x is 2 here. So I'm going to just go ahead and darken these a little bit better, like this. And so f of 2, so here's the function f, that's the one that's above here. So f of 2 means I got to find this y value. So when x is 2, what's that y value right here? That y value is 3. Plus h of 2, so h of 2 is this one. So Here's where x is 2. I got to find this y value. This y value is a negative 6. So 3 plus a negative 6 is 3. So the answer you're going to say is that f plus h at 2 is equal to 3. All right, so when you add these two y values, when you add those two y values, you get a y value of 3. Okay? B. In B, you want to find h minus f at 9. So h minus f at 9. So just remember, when you have a subtraction, the order matters, so you got to put h first. So by definition, that means h of 9 minus f of 9, right? So h of 9 minus f of 9. Okay, so I got to find these y values. So I got to figure out, well, when x is 9, what's that y value? When x is 9, what's that y value? And so I'm going to go to my graph, and here is, oops, I guess I should have, okay, there's no 9, oops, 9's here, I'm sorry. I was looking at the wrong one. All right, so here is 9 right here. So I'm going to darken this and this. Y'all agree? Okay. So this is h. I got to use h first. All right, so that's h right here. So what is h of 9? So what's that y value when x is 9? So this y value right here, use your rule if you got to, this y value right here when x is 9. So do you agree that the coordinates of that point is 9, 3? So what's that y value? The y value is 3. Okay? So if you need to label the points, and go ahead and do that. I'm not doing it because it'll make it look a little bit messier. But if you got to, go ahead and do it. And then f of 9, that's just right here. So if I want to label that point, when x is 9, what's that y value? So the question is, what's this y value right here? Well, that y value is 5. So the point here is 9, 5. So that means that when x is 9, my y value is 5, and that's what this is right here. So you're subtracting 5. And 3 subtract 5 is a negative 2. So your answer, you're going to say h minus f at 9 equals negative 2. Okay? C, you're looking at a quotient of f and h at negative 1. So C, you have f divided by h at negative 1. So again, by definition, that's f of negative 1 divided by h of negative 1, right? So I remember we quotient the order matters. So you got to find f of negative 1, and that goes in the numerator, not the denominator, the numerator. So negative 1, so remember, this says when x is negative 1, you want to find two y values, one for f and one for h. All right, so when x is negative 1, I have these 2 points right here. Y'all agree? Here's negative 1. I have this point, and I have this point. And if you want to label them, you can. So this is negative 1, 5, and this right here is negative 1, negative 5. Okay? So that's negative 1, negative 5. All right, oops, sorry, negative 6, excuse me, negative 6. All right, negative 6. Negative 5 is right here, so that's negative 6. Okay, so f of negative 1, remember, you got to make sure you use the right one. This is your function f. So f of negative 1, when x is negative 1, what's the y value? The y value is 5. So 5 goes in the numerator. The denominator is h of negative 1. So the question is, when x is negative 1, what's that y value? The y value is negative 6. So I'm going to write this as just negative 5, 6. All right, and so there's your answer. So your answer, you're going to say f divided by h at negative 1 is negative 5, 6. All right. D. All right, in D, you want to find the product of h and f at negative 7. So D, h times f at negative 7. So that means h of negative 7 times f of negative 7, right? Okay. So when x is negative 7, I got to find the y value for h and the y value for the function f. So negative 7, if I go and I label those points, that's this right here. So those are the endpoints right here. So that's this one, and that's this one. And if you want to, these two, right? And if you want to label those points, it may help some of you to label those. So meaning that this point right here is negative 7, comma, and then what's that y value? That's 7. And this here, the coordinates of that point is negative 7, comma, and that is what? Negative 4? Negative 4. All right? And so h of negative 7, so right here. So h of negative 7, when x is negative 7, I go to my function h, that's this one, that y value is negative 4, times, and then f of negative 7, so I go to my function f, and so when x is negative 7, that y value is 7. And so a negative 4 times 7 is a negative 28. And so what I found is that if I take those two y values, 7 and negative 4, so when x is negative 7, if I take those two y values and I multiply them, I get negative 28. So your answer you're going to say is that h times f at negative 7 equals blank. You're going to put negative 28 in the blank. Okay? All right, so that was number 7. All right, let's look at number 8. Number 8. Okay, so number 8, you have this. Okay, now be a little bit careful here because this says f of 4 and this says g of negative 4, so be careful. All right, so I kind of changed it in this example because it's going to happen to some of you where you're not going to be paying attention and you're gonna mess up because you didn't read it very well. All right, so okay, so in letter A, I'm gonna go ahead and rewrite it here. So this is gonna be 8A, and so 8A, you have f of 4 plus g of negative 4. All right, so f of 4 plus g of negative 4. So I got to find f of 4 first. Then I got to find g of negative 4 and then add them up. All right, so be a little bit careful. Make sure you're using your right functions. So the first one says f of 4. So what does that mean? What does that mean? Where do I go? Well, I go to my function f, and I got to find out what's that y value when x is 4. All right, so here is your function f. So your function f is this quadratic function. G of x is this linear function. So here is x equal 4 right here. Y'all see it? And so here's the point. Here's the point. I'm going to go ahead and do that here. Here's the point on your quadratic function. So that y value is what y value? So when x is 4, what's that y value? That y value is 1. Okay? So what I found is this. The y value for f of 4, so when x is 4, my y value is 1. Plus, now I got to find g of negative 4. So here is negative 4 right here. Remember, this is f, this is g. So g of negative 4, that's going to be this point right here, right? So you got to find that y value though. So g of negative 4 means what's that y value? So if you want to label it, you can. That's negative 4 comma negative 7. Negative 4, negative 7. So g of negative 4 then is negative 7. And so now we're going to add these up and I get negative 6. So your answer you're going to say is that f of 4 plus g of negative 4 equals blank, negative 6. So what I found is that if I add this y value and this y value, I get a y value of negative 6. Okay? B. So B is the same idea. Okay, so be careful. Make sure you read carefully. This says I want to find g of 0 times f of negative 2. Okay, so g of 0 times f of negative 2. Okay, so let's find g of 0 first. So make sure you go into the right function. Okay, so I put that kind in there to make sure you see. You really need to make sure you have the right function. So x is 0. What's the y value for g? So x equals 0 is that y-axis right here. Okay, so this was what, g of 0? So here's my function g. That's the linear one. So that's this right here. So when x is 0, my y value is negative 3. All right, so negative 3. F of negative 2 now. So remember, f is your quadratic one. So negative 2, that's this right here. All right, so when x is negative 2, that y value is negative 5. And so therefore f of negative 2 is, so that's multiplication, negative 5. So a negative 3 times a negative 5 is equal to a positive 15. So your answer, you're going to say g of 0 times f of negative 2 equals blank, 15. All right, now let's look at C. C. Now this time, you see how these are different than this? So here you're using your algebra function. So f minus g at 4. So f minus g at 4 means f of 4 minus g of 4. So this time, notice that the two two x's of my domain are the same. Here they were different. See, these were different. Now they're the same. So that means this. That means, okay, since they're the same, I can just use my ruler. So x equal 4. And in fact, if you look at this, so x equal 4, the y value is the same in both, right? In the y value the same in both. So this is where the two graphs intersect. The quadratic function and the linear function, they intersect where x is 4. And notice the y value for both is 1. So that means this. That means f of 4 is 1. G of 4 is 1. You're subtracting them, you get 0. So the y values are the same. So if I subtract them, 1 minus 1, 0. Right? So your answer, then you're going to say this. F minus g at 4 equal blank. You're going to say 0. Now let's look at D. So D, you want to find the product at negative 4. So D, you want to find g times f at negative 4. Well, by definition, that means g of negative 4 times f of negative 4, right? And so the x is the same on both, so I'm just going to go ahead and use my ruler. So I'm looking at this point right here, and I'm looking at this point right here. All right, so let's go ahead and find g of negative 4 first. So g, remember, is your linear function. So when x is negative 4, what's that y value? When x is negative 4, what's that y value? The y value is negative 7. Times, now let's find f of negative 4. So f is your quadratic function. So when x is negative 4, what's that y value? So remember, that's your quadratic function. That's f right here. So use the rule if you got to. So when x is negative 4, here's your point. What's that y value? So that y value, negative 4, what's that y value? 1, right? So my y value is 1. And so negative 7 times 1 is a negative 7. And so your answer, you're going to say g times f at negative 4 equals negative 7. Okay, that's your answer. All right. Okay, we're almost done. Let's look at number 9. So number 9, okay, so you can't see all of it, so I'm going to have to kind of reduce this. So number 9, you're given, I had to put this on two separate graphs. All right, so here's the function f of x, and here's the function g of x. So meaning I had to put this in two separate coordinate planes. All right, so here's f of x, here's g of x. So f of x is this piecewise function, and then g of x is this function that looks like this continuous function that looks like that. And I just want to know one thing, though. I just want to know what's f times g at 3. That's all I want to know. So in number 9, this is going to be number 9. So number 9, I want to find, and I'm going to go ahead and put that one on here. So in number 9, I want to find f times g at 3. So f times g at 3, right? Well, remember, by definition, what does that mean? That means f of 3 times g of 3. Y'all agree? All right. So now notice I have those on two separate coordinate planes. So let's just do each one separately. So let me go ahead and expand this. So I got to find f of 3 and I got to find g of 3. All right. So it's not difficult. It's easy because remember, just like you did. So here is x equal 3. So here's my point. And remember, this is f right here. There's your function f. So when x is 3, what's my y value? My y value is 4. So I found this. So f of 3 is 4 times, now I got to find g of 3. So x is 3 right here. I'm going to darken this. So that means that if I label that point, that's 3 comma, and this y value is 8. So when x is 3, what's my y value? Y value is 8. So g of 3 then is 8. So I get what product? 32. So f times g at 3 equals 32. Okay? All right. So that was number 9. Okay, now number 10. Okay, now we're going to look at tables. So we have two more problems, and then we're done. So number 10. So now you're given tables. There's no big deal. You can still do this. It's very easy to deal with. So So I'm going to do the work on here because it's not difficult. Okay, so keep in mind this is what you're told. So when x is negative 2, remember that means this. f of negative 2 is 4. So these are your y values. Y'all agree? These are your x values. Make sure you understand that. So when x is negative 2, remember f of x and g of x are y values. So you got to make sure you understand how to read this. So x is negative 2, x is 0, x is 3, x is 7. So what this means is this. When x is negative 2, f of negative 2 is 4. That's what that means. So make sure you understand that. So that means that f of negative 2 equals 4. That means that f of 0 is what? Negative 6. That's what that means. Okay? That means g of negative 2 is what? G of negative 2 is what? 1. So make sure you understand that these are your y values and these are your x values. Okay? Because that's f of x, y, g of x, y. So those are your y values. Okay? All right. Now let's look at this. What is f of 0? So f of 0. So when x is 0, what's my y value for f? Negative 6. Y'all agree? So y'all agree that f of 0 is, I guess I should have put this negative 6 right here. Negative 6, right? So that's going to equal negative 6 plus, now we're going to find g of 7. So I got to go to g now. G of 7 is what? Negative 2. Y'all agree? When x is 7, what's my y value for g? G of 7 is negative 2. Make sure you understand how to read each of these. These are your y values. So what does that 8 represent right here? That 8 represents the y value of f of what? 3. Okay? So g of 7 is what? Negative 2. And so your answer is negative 8. That's your answer. Let's go to the next one. So this time you want to find g of negative 2. So here's g of x. Here's when x is negative 2. So what's g of negative 2? G of negative 2 is what y value? 1. Subtract. Now we got to find f of 3. So f of 3, so here's x equal 3. F of 3 is what y value? 8. And so the answer is negative 7. So g of negative 2 subtract f of 3 is equal to negative 7. Okay? Now let's do this one. Okay, so by definition, remember this means f of 3 plus g of 3, right? Okay. So remember, x is the same in both of them, right? X is the same in both of them, so that's easy. Here's where x is 3. So what's f of 3? F of 3 is what? 8. Plus g of 3. G of 3 is what? Negative 1. So what's the answer? 7. So when x is 3, my y values for f and g, you're adding them up. 8 and negative 1 is 7. So that's what you just found. Okay, here you want to look at the product. So that means g of negative 2 times f of negative 2. All right, so same thing. You're using x is negative 2 for both. So when x is negative 2, what's g of negative 2? What's g of negative 2? G of negative 2 is 1. Times, what's f of negative 2? F of negative 2 is what? 4. So your answer, 1 times 4 is 4. All right, g of the quotient of g and f at 3, so that means g of 3 divided by f of 3, right? So g of 3, so g of 3 is negative 1. Your denominator, f of 3. So f of 3 is what y value? 8. So I get negative 1, 8. All right? Now here, remember that means g of 7 minus f of 7. So g of 7, so when x is 7, remember what this says, what's the y value when x is 7? So when x is 7, my y value is negative 2. Subtract, negative 2. Subtract, now we got to find f of 7. So when x is 7, f of 7 is what y value? 2. So negative 2 subtract 2 is a negative 4. So that's your answer. Okay? So just make sure you know how to read these tables. So these are your x values. These right here are your y values because f of x is y, g of x is y. So these are the y values for your function f. These are the y values for your function g when x are these numbers. And then finally, number 11, our last one. And that's just one thing I want you to find. So the difference between this one and this one is that I put the whole thing together. So this is just one table with columns and rows. Here you have two tables. This is the function f, and this is the function g. All right, same idea, same idea. So you want to find this. So this right here means f of 3 plus g of 3, right? So this says I go to the table that represents a function f. So that's this one. So this table represents a function f. This table represents the function g. And so the question is, when x is 3, what's the y value? So what do you think it is? So these are your x's right here. These are your y's. So this is the one that says x is 3, right? So f of 3 then is what? 7. So that's 7. Plus, and then now I go to the table that represents g. So this is a table that represents g. So when x is 3, what's my y value? Which one do you think you're going to use? So this one that says x is 3, right? Right here. So when x is 3, what's my y value? Negative 5. So what's the answer? 2. So f plus g at 3 is going to equal 2. Okay? All right, so that was just some different problems with evaluating functions where tables are given, graphs are given, and then and then you had some expressions. So that was, I guess, these right here. All right, so things like this. All right, so just make sure you know how to evaluate functions when one of these types are given. Okay, so that's the end of this lesson.